Now they ask us to find the arc-length function for the curve y equals x squared minus 1/8 ln x, and they say we should take 1, 1 as a starting point. Alright, just as a reminder, the arc-length function is defined as an integral from some constant a to x, square root of 1 plus f prime of t. So take note, if this is x, this has to be t dt. There we go. So therefore, the first thing I need to do is to say, okay, f of x is given is just x squared minus 1/8 ln x. What is f prime of x? It will just be 2x minus 1/8x. However, take note, we want f prime of t, not f prime of x. So I'll change this to f prime of t. Take note, there's a square there. So f prime of t would just be 2t minus 1/8t. And we need to find 1 plus f prime of t squared. Alright. And that becomes 1 plus 2t minus 1/8t squared. And if you simplify that, you end up with 4t squared plus half plus 1/64t squared. Now, don't write this under the root because it becomes difficult to simplify. Write this as a perfect square. And the trick is you take the square root of the first term, which will just be 2t, square root of the last term, which is just 1/8t, and look at the sign of the middle term, it's a plus. Alright, that's how I'm going to write it as a perfect square. And therefore, my function, the arc-length function, becomes integral. Remember, your starting point is 1, 1. It means x there is 1. So it's going to be from 1 to x square root of 1 plus f prime of t squared, which is what we have there. So it's 2t plus 1/8t squared. Alright, dt. What do you observe? Observe that the root cancels with the squared, so you end up with 2t plus 1/8t dt. And if you integrate that, you just have t squared plus 1/8 ln of t. And it's going to be from 1 to x. If you substitute, you have x squared plus 1/8 ln x minus 1. Alright, so that's your arc-length function. Remember, it's a function, that's why you have variables there, x. Alright.